Hey YouTube, welcome back. Today we have the third. We have the third solution for the problem number 55 jump game. You're given an integer array called nums. You are initially positioned at the array's first index, and each element in the array represents your maximum jump length at that position. Return true if you can reach the last index or false otherwise. So let's take this an example. We have array nums. We have 2, 3, 1, 1, and 4. We can reach the end because we can jump one step from 2 to jump one step from index 0 to index 1. And from there, we can jump 3 steps to the end. Basically, as you can see, if I am at the first index, which is 0, I can jump one step or two steps. In this one, no matter how hard we try, we will not get to any result because if we try to jump 3 steps, let's take this example in here. That's a text. So let's try in this one. No matter how hard we try, we will never reach the end. So if we try to jump from the three, so if we take a full 3 steps, we will reach at 0. If we take 2 steps and from 2 steps we try to jump another two if we take 1 step and from 1 step we jump 2 steps, we will reach 0 again. If we try to jump 2 steps and we go to 1, we will reach again 0. And if you want to go to 2 again, so if you jump 1 from 2 you have two choices. You can jump 2 directly, and we already discussed that and we said that it's already 0. And if you jump 1, you will find yourself jumping 1 again, so it is again you will reach the 0. So there is no way that you can reach this last element. And the way we try to solve this problem is by using dynamic programming approach that will start from the end. Basically, we're trying to start from the end, and after that, we go to the beginning. It's basically a workaround. So how this will work? First, if we know that number one, let's just try to get away. If we know number one will not even reach the end, so any number will reach to number one, we will cut the process there because there is no need to try other numbers. So we need to create some sort of memoization to make sure that we are memoizing every single character. So let's start first by creating a memorize object. Basically, this will be like an enum object that we will assign. There will be an enum object, and we will create a memorize array that we give each number a value if it's good, bad, or unknown. If it's good, that means we can reach the end from this number. If it bad, that means we can't reach the end from this number. And if it's unknown, that means we don't know yet. So let's try. First, we want to create our memo array, and it will equals new array, which will be from nums dot length, and I would say dot fill index dot good dot unknown. Let's make it as unknown. Everything is unknown, and also we want to make sure that our last element it will be the value of the last element. It will be good because the point is to reach the end, so the end reach the end, so it's good. So it will be memo dot length minus 1. This one will equals index dot good. Okay. Let's make a for loop. So for let I equals nums dot length, and I guess I equals nums dot length to minus 2 because we were trying to compare these elements, not the last one. Minus 2, and I should be bigger than or equal. I should be bigger than or equals 0. and I minus minus, and let's close the for loop right now. And I would say I will calculate the farthest jump, so we will not overlap or overlay the array. Farthest jump will equals math dot min from I plus nums of I, or the nums dot length minus 1. So let's say that we are in here in this position in the second index and we have number 3. So we want to know the farthest jump. If I want to know the farthest jump, first I want to know the position of the index, and after that I will add to it its value. So from there I will know the farthest jump that we can reach. So because of that, we add I plus nums of I, and we have nums dot length minus 1. We want to make sure which is the less, so we will not overlap. After that, we'll create another loop. It will be let j equals I plus 1. Okay. Um, yum, j is less than or equals the farthest jump. Um, and j plus plus. Okay. I would say if the memo of j equals index the good, that means we can reach the end from this one. So I would say first I would say memo of I. If memo of j equals good, so memo of I also should be equals index of good, and we break and we return this one. We should return whether the first element, which is memo of 0 equals index dot good or not. Let's see why. So let's try first to run this one and see if it will work. It didn't work because ah, it should equals I plus 1. Yeah, let's submit. Okay, it did work. Let's try to describe everything again from scratch. So first we have index simulation. So the index object mimics the enum in Java, for example, making marking each position in the array as good, bad, or unknown. After that, we have the initialization of the memoization. So the memo array is initialized with all positions marked as unknown, except for the last position, which definitely marked as good since reach the end from the end is trivial. After that, we have the populating the memo array. First, we're starting from the second last element. As you can see, we're starting from the second last element. Let me to make it clear for all of us. So we start from the second last element since the last element is already good. The function calculates the farthest index that can be reached. We have this farthest here from the basically we try to find the farthest element that can be reached from the current index. Um, After that, it then checks each index j that can be reached from I. Okay, we try to reach every index of j that can reach from I. Um, if any of these future positions are marked as good in the memo array, the current position is also marked as good. And the loop breaks early for the current I since it's confirmed to lead to a good outcome. And after that, we have the return status. The function returns true if the starting position uh, index 0 is marked as good in the memo array, indicating that the end of the array is reachable from the start. So this is how it works. And if that further, let's say that if the current element is 0, so basically the further jump will be 0. There's nothing to jump in. So the further jump, it's basically the range each eye can jump in. So let's submit again and see our own. Maybe later, please. I'm beating only 16%, and the next video I'll try the greedy algorithms with a greedy algorithm, which is way more advanced than this one. So until then, thank you for watching this video, and I hope you like my content. If you like my content, subscribe and hit the notification bell so you'll never miss a video. And see you in future problem. I have to stop recording. Ah, okay.